Hey there. Today I wanted to go over the basics of the so-called options Greeks. Now this is a topic that a lot of people find confusing, and it is one that one can go into a lot of mathematical detail. However, at a basic level, I think that's not necessary. So today I'm going to quickly go over a high-level view of a couple of the options Greeks, discuss what they are, what they mean, and how we might use them in our trading. So like in the last couple of videos, I'm going to switch between a presentation and a trading platform. So let's switch over now to the presentation and get started. So what exactly are the option Greeks? And I'm going to use as little math as possible here. So the option Greeks can be thought of almost as sensitivity indicators. They will tell you how much an option price, approximately how much an option's price will change when some underlying quantities, for example, the stock price, changes. So it can give you an estimate of the change in price of an option given the change in some other quantity. So you can draw an analogy between speedometers or accelerometers, for example, in a car. If you're driving at 60 miles an hour at a constant speed for a quarter of an hour, you could calculate that you moved a total of 15 miles. So given this quantity, in this case speed, you can calculate a change in position. Likewise, acceleration gives you the change of speed as a function of time. So given the acceleration, you can work back to the change in speed. Given the change of speed, you can work back to the change in position. And the option Greeks are very much like that. So they give you the change in the option price given a certain change in some other quantity. So they're called Greek specifically because they're designated with Greek letters. So the ones I'm going to go over here are actually delta, gamma, theta, and vega. So vega is not a Greek letter. The Greek letter is new, but for some reason people call it vega. So the first of these we're going to talk about is delta. And delta will give you the change in the option price as a function of a small change in the underlying stock price. And as I've said in a previous video, delta is also the theoretical number of shares that that option represents at that given time. The Greek gamma is a little bit more complicated. It's a so-called second order Greek, and it gives the change in delta given a change in stock price. So delta is not constant, it's going to move as the stock moves around. Gamma will tell you approximately how much that delta will change. Theta, as a premium seller, theta is very important for me. Theta will give you the change in option price per unit of time. Okay, so options are going to fluctuate depending on how much time there is till expiration. So as the time goes down, an out-of-the-money option will become worth less and less, and theta will give you a rough approximation of how much that will be. And last but not least, vega is the change in option price per unit of volatility. So let's go into these in a little bit more depth, starting with delta. So delta, as I said, is just the change in stock price divided by, the change in option price per unit of the change in stock price. Okay, so for a small change in the stock price, you can calculate the change in the option price just by this formula down here. So, example, if you have a $30 30 delta option and the stock moves 1 plus 30 delta, the stock moves $1, you would expect to make that option to change in price by 30 cents. And coincidentally, delta is approximately equal to the probability that an option will expire in the money. So a 30 delta option will have, give or take, a 30% chance of actually expiring in the money. So delta, as I said, is just the change in stock price divided by, the change in option price per unit of the change in stock price. Okay, so for a small change in the stock price, you can calculate the change in the option price just by this formula down here. So, example, if you have a $30 30 delta option and the stock moves 1 plus 30 delta, the stock moves $1, you would expect to make that option to change in price by 30 cents. You would expect this option to lose 21 cents in price. So instead of being roughly 5.60, it would be 5.39. And if we're to move $2, it would lose roughly another 21 cents. So that's all delta is. So let's go back now to the presentation and discuss the next Greek. So the next on our list is theta, and as I said at the outset, theta will give us the change in option price per unit of time. So there's a time decay component to options. Long options have negative theta. In other words, they lose value, all other things being the same, they lose value as time goes on until they drop to zero at expiration if they expire out of the money. On the other side, short options have positive theta. So if you're selling options, that's what you want to have, this positive theta, because as the option price drops, you eventually want to buy it back for as little as possible. Go. So switching back over to the trading platform here, if we look at this 21 delta option here, I have theta up here. So this option is going to lose. And this is a bit complicated here because the factor of 100 is already considered into this price. So remember, if we bought this option, we would be paying over $560 for it because it's $5.60 times 100 shares of stock per contract. So if we were to buy this option and nothing would happen for a day, we would expect this option to drop by $10 in value. On the other side, if we had sold this option, that drop is good for us. And down here, Tasty also gives us the theta value. It's down here. Again, it's a little over $10 positive because I've clicked sell. And again, these things add. If I were to come up here and just double the amount of contracts, so 2 contracts was now I have a positive $20 theta, 3 contracts, $30 of theta. So if I were to sell these 3 contracts and the stock went nowhere for the next few days, every day in principle I would be earning this amount of money, or $30. So gamma is a little bit of a more tricky one here. It's kind of like the acceleration of the option price. So if speed would be delta, gamma would be the acceleration. Now, I don't pay that much attention to gamma. There's something called gamma risk, and the way I trade, I very rarely trade options that have a very small time to expiration, like a couple of days, and that's when gamma can get you into trouble, at least if you're not trading huge quantities of options. So the last on this list for today is going to be Vega, and Vega is the change in option price per change in implied volatility. So again, it's a metric of volatility risk. Okay, long options are going to have positive Vega. So if the stock does not move and volatility increases and you're long that option will increase in price, which is good for you. If you are short the option, it has a negative Vega and its price will drop with decreasing volatility. So as somebody who sells option, we want to sell them into high volatility, hoping that it will go lower. Because if we're we're selling options when volatility is low, there's less money to be made, and then there's always the possibility of volatility expansion, which would hurt a short options position. So I don't pay that much attention to Vega as such because it's related to theta. So a long Vega option is short theta. So a long option is long Vega, and that's short theta. So theta kind of gives me an idea of my volatility risk. So right now, when I'm recording this video, we're in a low volatility environment. So I'm worried about the possibility of the market selling off and volatility expanding. Therefore, what I want to do is reduce my theta number so I have less volatility risk. Yes, I'm earning less money per day, at least in theory, but if the market crashes, I do not have that so-called Vega risk. And that's going to eliminate some portion of my risk, because if there's a big down move in the market, my positions are going to go from delta neutral, where my deltas all average out to 0, to delta long because of gamma. But also I could end up losing on that volatility expansion, because as the market sells off, volatility tends to go up. So I'm getting hit doubly hard in a big sell-off. So that's why my theta positions right now are kind of low. So that's an awful lot of information for one video. So in future videos, when I'm actually doing on trades, I'm going to discuss these numbers, what I'm going to collect in theta premium, what the deltas of the positions are, and what that means in terms of option price changes and what I'm hoping for based on these Greeks, because the theoretical overview is good, but I think it's too much information to take in at once, and you need to see it in action to be of more use. So the next trading video I do is going to be I'm going to discuss this more. So that's it for today. If you have any questions, please feel free to leave them in the comments. If you have any suggestions for videos, again, please feel free to leave them in the comments. And if I can, I will get around to making them. And that's it. So good trading and see ya.